Hello, welcome to another episode of Xan Talk Show. Today we are going to code Emacs Lisp. We are going to continue from last video, writing a HTML validator in Emacs Lisp. Okay, so good morning everyone. So if you have questions, comments about Emacs Lisp, post it. Okay, so we're gonna focus on Emacs Lisp. And we're gonna complete the task. You don't have to watch yesterday or the day before video. Fantastic, because I'm gonna cover it. Okay, so let me show you my keyboard. This is Ultimate. This is the Glove 80 keyboard, and over there is Ultimate Hacking Keyboard. Just search for Xali keyboard blog. You'll find my reviews, including video reviews. Okay. So now let's go start to code. Let's show today's page. Okay, so let's start. So we started to do it yesterday. That's 90 minutes. Very interesting. I mean, I explain as I go. But today we're gonna continue that task. Okay. So first of all, so I'm using Xafly keys. Let me show you. Okay, I'm using Emacs, of course, and I'm using all my custom mods. You can see CSS, HTML, Emacs Lisp, Golang, HTML, all my Emacs code. And the key binding I'm using is Xafly keys over there, showing browser. So you can download it and use it. It's a key binding system for Emacs, so that you don't have to press Control key or Meta key much, almost none. Okay, so Xafly keys, and I'm using a Vorak keyboard layout, so you can see Vorak. Okay, and on the pink window is all my command core and keystroke on the left. Okay, that's on the pink window. So whatever I'm doing, for example, select that, delete that. You can see the command I just called XHTML select tag element. Okay, undo. There it is, undo. Okay, so let's begin. Immortality, hello Susie bra. Hello you guys. So Emacs Lisp, okay. So and I like to thank this person. Actually, I don't know this person, Cliff. Okay, he's got 100,000 followers. Every time he retweets my tweet, I get tens of notifications and some new followers. So thanks to Cliff. So he retweeted my Emacs live stream, and now it's 2,500 views. Usually it's just 100. Okay, so and I'm on Twitter, so follow me on Twitter, and also I'm on Discord. Just search for Xali Discord. Okay, so let's begin coding the real stuff, the coding. Okay, so first, so we need to go back to yesterday's get the code. So here is the yesterday's page, Xan Talk Show. 2 days ago. So here's the code. Let's grab it. So get that code. Let's just work on this. Yeah, let's create a new one. So copy it, close. Okay, go to today's talk show, and new buffer, paste it, and copy the file path. Actually save it. Okay, save it. Let's say xxx.el for now. Okay, so just run the name, copy it, close it, paste the link here, linkify. So we have a record of the code. So later on, you can grab the code. So we continue to write a HTML validator. Now, let's create a new buffer, and let's insert some HTML, HTML template, so we can test on validating that HTML. What is that? So there it is, a template. Okay, so this is the template we're gonna work with. Yeah, so we need a slash here. So Okay, so this is a sample file. So we write a command. We can meta x call the command, and it'll validate. It'll tell us if it's valid, or not. Mismatched tag or missing tag and so on. So yesterday, so you can, I always write documentation. So here's the documentation. So if you are late, you can watch. You can read there to see what we are doing. So the command yesterday we did is this one, okay? XML validate buffer, okay? Let's add today's date, a new version. Okay, so let's begin. Okay, video check, audio check, yeah, good to go. Yeah. So okay, so let me briefly go over what we did yesterday. So here is the code. Let's hold on a sec. Let's clean up. Okay, so let's remove the parts that we don't want. Okay, so remove that, and this one we can actually also remove. We are using it there. Anyway, so so yesterday's code. Let's hold on a second. Can you see? Yeah, you can see it. Okay, so it's a trailing slash needed for self-closing tag. Okay, yeah, you were here just yesterday, are you? Because we covered that yesterday. So in short, in XML, if you have a self-closing tag, that is a tag without a closing tag, that's called self-closing. You can call it self-closing tag. The technical name is void element. Okay, why don't we repeat that? Okay, so you go to just search for XR JavaScript in depth and click on HTML. Then you go here, self-closing tag. So these tags, they don't have a closing tag. Sometimes they do have a closing tag, it's optional. So technically they are called void elements. It's kind of confusing, so in XML, you always need the slash, okay? Whenever you have a tag, then that tag ends with a slash right bracket. That means it's self-close, okay? But in HTML, technically, that slash is not allowed. But however, because, over the past 20 years, because the mix of XML, HTML, HTML5, XHTML, it's one fucked up fuck. So today in HTML, you can also have that slash. But in XML, that slash is required, okay? So that's the bottom line. We talked about that yesterday. It's XML is much better because because you can purely via syntax you can judge which tag is self-closing, but in HTML you cannot. So anyway, so here's a sample HTML file we're gonna validate, and then we start to code. Yeah, so let me go over yesterday's code. Okay, so first of all, we have this function. XR is self-closing. It takes a string. So basically like that, takes a string of a tag. And if the second to last character is a slash, then it's a self-closing tag. So this function just returns true or false. We do by checking the substring. Okay, so it's self-closing. So that is that function. Now let's go to the main body. Let me go over to show you what we are doing. So this XR validate HTML buffer, it'll just validate the current buffer. So first thing it does is go to the beginning of the buffer, go to chart, get the current cursor position, find the next angle bracket position, grab the text in between, and that's one tag, and push it to stack. So go to the beginning of a character, and we do a while loop here, then okay, let's magnify. So while loop, then we search forward for left or right bracket. So we go to the beginning, search forward for left or right bracket there. Then if that character is the left bracket, then we set the cursor position to XP1, which is right here, the beginning of the tag, basically. If the angle bracket is not a left bracket, then it's an error, because we have a situation like that, then that's an error right away. So you'll just stop the program and report it. So let's, we can run the program and try it, okay? So run it and copy the file, command name, metax validate XML buffer, do it. You can see at the bottom it says error found at position 3. So it caught there. And that is caught by this line. Okay, so once we found the left angle bracket, we search for another angle bracket. And if that is the right angle bracket, that means we found a tag. We found a tag. So then but for substring no properties, we grab the text between the two positions, XP1, XP2. Then we check if it's self-closing. If it is, do nothing. Otherwise, we push it to a stack. Stack in here, a stack is in Lisp. Stack is just a list, okay? A list of items. You can always add items to the front or remove items from the front. Okay, that's a implementation of stack in Lisp. That's just a list. Okay, the most natural implementation of a stack data structure in computer science in Lisp languages. Okay, except Clojure. Clojure has something else because Clojure is based on Java data structures underneath. So anyway, so we push to the stack. Okay, when the tag is not self-closing, then we push to the stack. Then the code prints a stack, and that's it. You see that's it. That's it of yesterday's progress. And if we call it here, let's remove that. So let's call it, and you go to the messages buffer. You can see here is the stack it printed. So we open a new buffer, then we paste it, then we make it each of those items into a line by itself. So you can see that's a stack we have. Now the next thing we want to do is we check each one. So the bottom one is the bottom of the stack. So you go by for each item in the stack, you check the next one. For example, right now, suppose we are on head, opening head. Then we check next one. That's also opening tag title. So whenever you see an opening tag, skip it. Go to the next item. Then whenever you see a closing tag, check to see if that closing tag matches the previous tag in the stack. If it does, then just delete them. Like remove them, because it matched. It means well formed. Okay, so then you repeat. So at the end, if the file is valid, then your stack will be of nothing, of no items. Okay, so if otherwise, then you got an error, mismatched tag. So that is the algorithm. That's what we did yesterday. So today, so far. So close that. Okay, so so far our code didn't do much. Our code, the only thing it checks for error is something like that. The mistyped angle brackets, but it doesn't actually check any stack yet. The matching tag. For example, we copy the HTML, paste it again here, so it's repeated. It should be invalid. So, but the code doesn't do anything yet because it doesn't check the stack yet. So today, we are going to continue the code so it actually check the stack Okay, so now undo to remove the duplicate. Well, let's leave it. Let's leave the duplicate HTML there. So today we are going to check the stack. Okay. So check the stack. So we pushed a lot of things to the stack yesterday, but actually, one of the most important thing to validate the tags is that you want to know it's opening or not. Okay, so you want to know opening tag or is it a closing tag? Closing tag always start with a slash. Okay, so you want to know it's opening tag or closing tag. The other one, most critical thing, is you want to know the tag name, because only the same tag name can match. Okay, otherwise they don't match. You have to keep going. So the two most important thing is the tag name and its opening or closing. So let's write a function to do that. Okay, so then we push the information to the stack. So the stack, instead of just a tag name, we push several informations. We push the information we like to have is the beginning position of the tag, the end position of the tag, and whether the tag name, and whether it's opening or closing. So we find all this information and push it to stack as one item. Okay, so let's do that today. So we have a self-closing tag. So we want a function is opening tag. Okay, so we can write it, or I already defined it before. I already defined it in my HTML mod. So let's use the existing code so we don't have to waste so much time. So let's go to this keystroke gets me to XML HTML mod. Enter to open it. Here's the source code. Then list matching lines. Okay, let's show the pink window. Then list matching lines, we want to match for open, something open tag. Okay, so here's a function. XML HTML opening tag P. Any function ending in P means it's a predicate. Predicate means it's a function whether it returns true or false. Okay, that's a Emacs Lisp convention. Ending in P means it returns true or false. Okay, so we have a function here. So we have a function here. XML HTML opening tag P, true or false. Return true if tag is opening tag or self-closing. Okay. Else return nil. Okay. Now this function takes a position in the buffer. Okay, so tag begin, the parameter, the argument must be on the left of angle bracket. Okay, like that. Okay, so we already have a function. Why don't we grab it here? So copy it, close it, close it, close it. Okay, so we already have a function. Let's paste it there. Fantastic. So all we have to do to call this function is, let's just start to do it. Okay, so let's go back to our code here. So let's add a variable is x is open. Okay, by my variable naming convention always start with the x, so that they are highlighted, all the variables. Okay, so x is open. So let's before we set tag, let's see, where do we add this? So yeah, so while we find, so here is a tag, set is open. So before we, so this function opening tag true, I mean whether it's opening tag, it takes a cursor position, okay, not the tag name, but we can also, it takes a cursor, you know, there are many ways to go about. You can make it to take a string, which is the most simpler conceptually, or you can make it take a cursor position, which is more efficient, because that way you don't have to actually grab the thing as a string. So this function right now takes a cursor position. Okay, let's just do that. So now we need to, first of all, we need to move cursor to, the cursor position is XP1, because you remember we search forward for the bracket, and if it's open, then if it's a left bracket, then we set it the position to XP1. So it's open, so we can just call, here is how we do. So call this function, give it an argument xp1, okay, that will return whether the tag is open or not. So that's one information. And so that tells us the tag is open or not. Then the other thing we need is a tag name. Remember, we need the tag name. So to get the tag name, we also have a function already written. So let's go back, let's open the HTML file. Then here is a function, HTML get tag name, okay? We're gonna use this function, okay? So why don't we copy it, close, and we also define it here, okay? So these two functions, let's move it to the top. Let's move it to the top. These are standalone functions. You know, these two functions are standalone functions. So this one gets a tag name, copy it. Now we're gonna use it. Okay, so first of all, let's define a variable tag name. Okay, so let's move here. Okay, so tag name. Now let's set tag name to be, call this function. Then what is then you need to pass a position, remember? Yeah, so the position needs to be to the left of the left angle bracket, so that would be also x1, xp1. Okay, now prettify the code. So now we get the tag name, we get the tag, we get the tag name, we get the is it open, okay, and yeah, so that's what we want. Fantastic. Okay, so first of all, okay, so this we need to, so if it's self-closing tag, then we don't push to the stack. Otherwise, we do push to the stack. So first of all, what we're gonna push to the stack, it's going to be a vector. Okay, so a vector in Emacs Lisp, a vector is a data structure in Lisp, which is similar to Python's tuple, okay, or to C's array. Essentially, it's a list of items of fixed length. You can never add to it. You cannot remove item from it. Fixed length list, essentially a fixed length array. Okay, typically it's called array. So that's what vector is in Emacs Lisp. So here we have a vector, and the so what we want the stack item to be. So we need to be X is open. Oh, we got the, did we get the heart? I saw the heart. How does that work? So vector is open and tag name. So we want to vector first item is open, then tag name and beginning position, end position. Okay, so beginning position xp1 that's where the tag begin, then xp2 that's where the tag ends, then tag name, then is it open. Wait, how does that heart work? Fantastic. Okay, am I doing good? Comments. Okay, video check, audio check. Oh, great, fantastic heart. Okay, so here is the thing we want to push. Okay, so beginning cursor position, end cursor position, tag name, and is open. Okay, and we push it to the stack, right? So we check if the tag is self-closing. If it is, do nothing. Otherwise, push this to stack. Okay, fantastic. Okay, that's our code. That's pretty good. That is our code. Pretty good. So yeah, so now our stack will be reach, is gonna be reach now. So let's see. So is self-closing. Okay, let's cut this, move to the top. Okay, so describe list matching lines define. So right now we have this function defined. The first three is help functions. This is the main thing. So go to there. So there it is. It's only about 40 lines. Okay, so now we eval the buffer. Now Emacs knows about the whole list of functions. Now we meta-x XML validate XML buffer, do it. Fantastic. Now we open the messages buffer, copy it, open a new buffer, then we make them into a line by itself, make each item on a line by itself. So here's our stack. Oh, fantastic. So wait, tag name is open. Fantastic. This is now simpler. So we got the, you see, so here's the first tag is HTML, beginning position, end position, then tag name, then whether it's opening tag, true open. Okay, so this is open, open, close tag, neo is close tag. Fantastic. Now we got it pushed to the stack. Okay, so what so now fantastic. Now it's great. I'm doing good. Thank you, Seal. Okay, so what's the next thing to do? So those comments, we don't care. Okay, what is the next thing? Let's move it. That's some comment from yesterday. Yeah, so we now we need some code to check the stack. Okay, so remember, here is a while loop. This while loop, is going through, by searching the brackets and each time push a tag to the stack. Now we can, so after the whole thing is done, we have a bunch of stacks. we can check it, you know, or we can check it as we go, you know, before you even, you know, like we can check it after the whole loop, or we can check the stack while inside the loop. So which one should we do? So here is a thing we need to think about. We can check the stack during the loop, or should we check the stack after the whole? If we check the stack after whole, it's less efficient, because suppose you have a huge document, let's say 10,000 lines. Now you know the error occurs on the 10th line. So if you check the stack while doing the loop, you'll find it right away, and the program can stop, you know, then there's error. Or if you wait until the whole loop is done, it has to read all the, you know, 10,000 tags. So it's better. It's probably better to check during the loop. But the other concern is which one is easier to write, to implement. Because if you have the entire stack, then the way you validate it is by, you know, you go to the last item of the stack, then you check if it's matching the beginning. If it does, you have to remove both. So you have to actually operate from both sides. You know, our stack is a list data structure. So with a list data structure, it's efficient only if you add or remove the first item, you know, the top of the stack. If you want to remove or change the bottom of the stack, it's very inefficient. So that means if we want to wait until the whole loop is done, then process the stack, that means the list data structure is not suitable, because it's gonna be very inefficient. So right now we know it's probably better to check the stack during the loop within the while loop. Okay. So automatically launched the heart. Is that so? You are doing good. Important to time yourself while coding. Time. Sorry, I'm bugging you, but would you be able to provide resource to detecting AMD identifying a keylogger on Windows 10 operating system? No, I don't know anything about that. So you want to detect is if there's a keylogger on Windows. No, I don't know how to detect that. All you can do, all I can recommend is you download the virus checker. Otherwise, I don't know. That's another topic we can talk about another day. So we want to check the stack during the loop. Okay, that's more efficient. But how do you do it? Okay, so you so here's the stack. Suppose we are here, and then we just one more loop, we read one more stack, so we are here. Then you want to check the stack. So if the current stack is closed, okay, so if it's open, ignore it. So we move on to the next loop. If the current tag is a closing tag, that's when you need to do something. Okay. if it's closing tag, then you check the last item on the stack if that's the opening tag and the name also matches. If so, you remove it. Okay, that's the algorithm. Fantastic. Thinking does it. So let's write it out. If the current tag is closing, then check the last item on the stack. If it's opening and tag name match, then remove that on stack. Fantastic. That's the way to go. That's what we're gonna do. Okay, so now let's refactor the code a little bit. So here, if it's self-closing tag, okay, let's move this code to here. Okay, so to make it more efficient. So if it's self-closing tag, do nothing. Otherwise, we gotta do something. Okay, otherwise, okay, let's move the code here. Okay, does that make it simpler? So get the tag name. If it's self-closing tag, do nothing. Otherwise, actually we don't even need the tag. Yeah, so we don't even need the tag. You see, the only reason we need the tag is because this function is self-closing. This function we wrote here, that takes a string, the tag string. But I already have a function that checks if something is self-closing without needing a tag string. So you see, if it's self-closing, do nothing, right? Otherwise, get the tag name, check if it's open, then push to stack, right? So, but however, the entire tag, opening or closing, the tag itself is never needed. It's never needed anywhere except by this function. Therefore, we don't need it. We just need to know if it's self-closing or not. We don't need to actually grab the tag. Okay, so now let's write a self-closing predicate function that do not require a string, the tag string. Okay, so let's go to my HTML mod again to find the function HTML mod. So we want to find self-closing. Okay, list matching lines self-closing. So here is a function, jump to it, search for it, there it is. Okay, so here is a function HTML tag self-close p, and it checks by whether the tag name is in this list. Let me show you. Okay, so here, so you see here is a bunch of self-closing tags. Okay, so now we just grab this function. Okay, close, go back here, we paste the code here, and we don't need this code anymore. Okay, and so now this is a new function. Now let's go down here, self-closing we don't need, so we need a new way to check, and this function takes a tag name. Okay, so actually it takes a tag name. So it takes a tag name. So now remove this line. Now a tag name, so you need to set the tag name before. You see it's called here, so you move this line to here. Okay, prettify the code. And this tag we don't need anymore. That's right. So remove it. Okay. So we got the tag name. Now check if it's self-closing. If it's true, do nothing. Otherwise, do this. Okay. So if it's not self-closing, then check if it's opening tag. Okay. And now check if it's open, do nothing, nil. Okay. Otherwise, let's put a comment here. Otherwise, we need to check the stack. Okay, let's prettify the code. So get the tag name. If it's self-closing, if it is, do nothing. Otherwise, is it opening tag? If it's true, okay, so set is open. So if it's opening tag, then do nothing. Otherwise, check the stack. Okay, so otherwise, now we check the stack. Now, so let's put a comment here. Now we check the stack. So if it's a closing tag, now if X stack, now we need to get the element of our stack. Did we document? No, we didn't document it. So let's document the stack. Okay, let's document our stack here. Stack is an empty list to begin with, and the list, each element is a vector and of this form. Position, cursor position, cursor end position, tag name is open. Okay, that's a vector. Stack is a list. Okay, each element is a vector like that. Okay, so that's a document of the stack. Okay, now let's go back to here. So position name is open. Okay, so if so a vector, we how do we get the, so we need to get a vector. Vector is 0 indexed, and so we want to check the name and is open or equal. Okay, so if something. Okay, so if string equal tag name equals to the item on the stack. So here you need to get the last item on the stack. So you can do that by car. Okay, so car x stack is actually a list. So car x stack gets the first element. So if that element string equal tag name, so that element is a vector. right? It's a vector like that. So that element, so now we need to extract the tag name from that vector. So that function is arref. So array is that, and index is 0, 1, 2. 2 is the tag name. Okay. So if that is equal, and we need another thing we need to check. Okay, so now go back. So if that and if the last item on the stack is a opening tag, that means opening tag, that means T. Okay, so and let's see. Okay, so let's. So the last item is 0, 1, 2, 3. So third item. So if the third item of the last element on the stack is T, means it's open. Okay, so the name match and the last item on the stack is open, then we, okay, clean up the code, then we pop, remove the item on the stack. Okay, so if that is true, then pop the stack, otherwise push to the stack. You see, now it's all clear, otherwise push to the stack. Fantastic. Okay, does that make sense? So here's a code to check stack. We already did it. Clean the code. No, too much nesting. Okay, but still. Does that make sense? Actually, I think it'll work. One-shot coding. I'm out of coffee. Okay, so let's double check. Okay, so get the tag name. Get tag name. So let's look at our file. So we get the tag name, then check if it's self-closing. If it is, do nothing. Otherwise, check if it's opening tag. If it is, if it is, we need to push to stack. Right. So if it is, we need to push to stack. Otherwise, we check if it's a closing tag. Otherwise it's a closing tag. We check if it matches the tag on the stack. The tag name is the same or not. And the last item on the stack is open. If so, remove the last item on the stack. Otherwise, push. Okay, I think that's it. Are you gonna show live memory run for the runtime? No, we don't care about that. There's very little memory. Okay, even if you have 10,000 stacks, that just means a list of 10,000 items, and each item is a vector like that, a vector of 4 things. So even if you have 10,000 of them, it's like trivial, one few microseconds, because today's computer are very fast, unless you are talking about 1 gigabyte file or something. But that's not practical. But because most HTML files, 10 megabyte at max. Okay, yeah, you are not going to deal with 1 gigabyte HTML file. So it's shouldn't be a concern. So we focus on, okay, so practicality. Okay, so this code works. I'm pretty sure. Let's run it. Okay, it's already run. You see run current file, so Emacs knows the new code. Now let's test it on this sample file. Call it, do it. Okay, so what happened? Oh, let's look at the stack. Oh, so now the stack is very short. Actually, that's correct. You see, because remember we have a duplicated HTML tag. You see, so that is why that HTML tag remain on the stack, because it's never matched. But what is this empty string? That means a tag without a name. What? Yeah. So it's working fantastic. Now we just have some bug. So what is the so this mysterious thing? Oh, okay. So it's number, you see, position 3. There. I think that's that one. Yeah, I think so. So position 3 to 18. So if you can, now you can call describe char, and Emacs will tell you what position your cursor is on. You see 18. So position 18 is right here. So that means this line, this element is this thing. Now that thing should be considered, that's a doc type. Technically, it's not a tag at all. It's just one declaration. Technically, according to spec, that's not a tag. But for our purposes, we can consider that to be a self-closing. But why is our self-closing tag doesn't match that? Let's see. Get tag name is opening tag, self-closing tag p. So let's look at the variable. Okay, so HTML self-close tags. Okay, so it should be there. Self-close tags doc type. Because we consider that to be self-closing. Now maybe the tag name, our get tag name function is incorrect. So let's look at it. Describe function, jump to okay. Actually, okay, so why is it not getting, oh, there it is. That's why, because it doesn't consider the exclamation sign to be part of it. That's why it becomes 0. So let's check tag name. So how does this code work? So it takes a tag beginning position. Okay, then then go to char tag begin forward char looking at, if looking at, then forward char. So if it's the tag name start with that, skip it. Otherwise, set point. So skip char forward. Yeah, so you see that's a problem. So the code stuck over here, so that's why you get an empty tag name. But here you should include, this is one of the, you should include an exclamation here. You see, this is one of the problem of the irregular syntax that creates. Suppose if you have a clean XML, not even XML, but suppose you have an XML where the syntax of the language is, there's nothing special, because right now this doc type is considered special. So you can say, that's even not a tag, its declaration is not a tag, but you shouldn't, but if everything is just a tag, then it's regular, it's much easier to deal with. So anyway, so to solve that problem, all we have to do is add a exclamation here, I'm pretty sure. So we can try it again, evaluate the buffer, go here, call it, do it, you see? Now go to the messages buffer, so you see, now we got just one item because that is the duplicated HTML tag here, see? Fantastic. Okay, now let's do some cleanup. Let's remove these, remove these, because all those are defined in my XML mod. So let's just go to XML mod, then we don't have to duplicate them. So wait, evaluate the buffer, close it. So what is it that we need? Tag name, yeah. So get tag name. So describe function, jump to the source code. We need to add a ban here. Ban, okay. Evaluate the code, add today's date, modification date. Okay, evaluate the code, go back here, evaluate the buffer, go back here, expand, call the function, do it. Fantastic. Now that's it. We're done with the program. One more thing to do, okay, to make it report the error. Okay, so here we don't even need to print the stack. So all we have to do is if length of stack 0, 0, let's hold on a second, let's try equal, yeah. So if length of stack is 0, then done. Perfect. You have perfect code. Okay. It's otherwise print stack. Well, otherwise, let's see. Well, yeah. Otherwise print stack, but before you print the stack, you also want to go to the last position. So car a ref, so get the last item on the stack and go to char, last item of the stack, and the zeroth index, that is the beginning position of the tag, and then you just say go to it, go to char, okay, go to char there. Okay, come on. Okay, so if the stack has nothing, then done, you have perfect code. Your code is perfect. Otherwise, go to the last item on the stack, get the position, put a cursor on the beginning of the tag of the arrow, and also print stack. Okay, eval the buffer, go back here. Now let's put a cursor here. Okay, let's say, and call the command, do it. Fantastic. You see, it puts the cursor right on the place, you know, the first error that occurs. Fantastic. Okay, now again, let's do some pretty thing. Let's say error. Okay, messages, error, you fucked. then it says, then we have to say, yeah, those error. Yeah, okay. So also, yeah, so error. Here's the stack. Okay, then also make sure the program, if it's valid, should return true. Okay, so let's do that. T for true. Actually, message, I think message returns true. Yeah, it returns a string. Yeah, okay, so when it's valid, this function should return true in case you want to call this function in Lisp code. Otherwise, it returns nil. Okay, fantastic. Eval buffer. That's it. That's it for today. You know, lots of talking, but 1 hour. We did it in 1 hour. Perfect. So total of 2 hours. We did it. Let's go to message buffer. Yeah, you fucked. Here's the stack. Okay, correct. Now let's remove this remove this duplicate. Okay. Now let's try again. Call it, do it, done. Your code is perfect. Thank you guys for watching. If you like my stuff, pay me. Okay, you can buy my Emacs tutorial. Okay, lots of, you know, go to, you know, just search for Xali Emacs tutorial, the most popular Emacs tutorial on the website. So you can PayPal me. There's a link there, PayPal or Patreon me. So thank you guys for watching. Any questions? Yeah, so we did it. Fantastic. So for those of you watching, you know, later on you can get the code offline. So let's hold on. Let's clean up the code. Okay. So, and put the code back to my page. So parse region, so we don't need that anymore. So here is the code, glorious code. 50 lines, 60 lines, 60 lines plus we used 3 built-in, you know, 3 functions I have written before. So a total of 120 lines, something like that. 100 lines, validation of XML and HTML code. Fantastic. Now let's make some error. So let's make some error here. Okay, let's say some okay, bold. Okay, now let's call the command, do it. Your code is perfect. Okay, but now let's put this end bracket to here. Okay, call the command, do it, error. So now let's go to the error, you fucked. Here's the stack, and it should put the cursor right there. So let's do it again. Do it. Oh, it didn't, because it didn't put the cursor at the right position, because the way we validate, so we can look at the stack. The way we validate, because yeah, so okay, here's what happens. What happens here is you have two. Oh, that's an interesting error. So you can't. The question is, can you discover this error while you are doing the loop? Can you? So the question is, well, so we found the opening tag, then we found the closing tag. Well, actually, you should be able to. But what is the mathematical property to know this is error? How do you know this is error? I mean, we know it's an error because our stack, they don't cancel out, right? So we know it's error at the end. But technically, you don't need to go to the end. Do you? No, because as soon as you have an opening tag, you need to expect it to close. Okay, so we have an opening tag H1, then we have an opening tag B, then we close the H1. At that point, we know it's an error already. But how do you know in code? What is the mathematical essence? How do you express, we humans, we know it's an error, but how do you express this situation that makes it error from a mathematical point of view? Because once you can do that, then you can turn it into code. So opening tag, so close. So whenever you close the tag, so whenever you encounter a closing tag, that closing tag must have a matching opening tag before, right before the previous tag on the stack. Okay, that's the thing. So whenever you see a closing tag, which is here, and that tag must have a opening tag on the stack. Otherwise, it's error right away. So we just have to modify the code here somewhere. But that's it. That's done today. So Fizzler Freeze says, I got an expose after your review. It hasn't arrived yet, but I'm excited. Thank you. I'm happy I finished the code today. It's basically good. So expose, I highly recommend it. That's one of the keyboard I love very much. I so much enjoy it every time I use it. Because I have so many keyboards, so I cannot use all of them as my main. So I have to, either use this one or that one. But all these, Ultimate Hacking Keyboard, Glove 80, Kinesis Advantage 2, and Expose, that any one of them I can use full time, no problem. But the Expose is flat, so that's a bit an issue if I use it long term. Okay, thank you guys. Thank you all. Pay me, okay? Remember, donate. That's because that's the most important. If you like my work, donate something. Okay, bye guys. Bye. Closing down in 1 minute. Let's just put a code. Let's put the code into my page. Make a backup. Close it. Close it. Close it. Show in browser. Okay, that's it. Bye. Thank you.